here I want to do is, in a prior situation, we found some equations that describe our shear force and our bending moment as a function of x. And what I want to do is take a few minutes to plot those into three different plots: one for the normal force, one for the shear force, and one for the bending moment. Just as a reminder, we started with this problem over here. That is a beam that is 7 meters long, and it has a distributed force of 1.5 kilonewtons per meter on the right hand side of that beam, the last 4 meters. And what we did is we did two cuts, and we found the equations for that describe my normal force, my shear force, and my bending moment between 0 and 3 meters. And then we did exactly the same, another free body diagram, and find the same equations or to describe that normal force, shear force, and bending moment from 3 to 7 meters. Now what I want to do is see how can we plot this. And let me see, let me find another piece of paper here. See, 22, 23. Very good. So what I'm going to do is I'm going to do an XY axis, where my x is the same axis in my free body diagram up there. My y now is going to change. For one diagram is going to be my normal force. For another diagram is going to be my shear force. And for a third diagram is going to be my bending moment. So let's just start with that. All right, this diagram, I'm going to do something like this. See if that worked. Okay, let me move this to the top and turn this off. Very good. And in this case, I'm going to do a diagram where this is x. I'm going to put here my normal. It's a function of x. I'm going to do another one where this is x. This is going to be, let's put my shear in here. And I'm going to do another one where this is x, and over here I have my moment as a function of x. All right, let's start with the first one. And let's go back to our prior page where we looked at the normal forces, right? So we found out that for between 0 and 3, that normal force was going to be equal to 0. And between 3 and 7, that force was also going to be equal to 0. So I'm going to change my color here. I'm going to do, let's use the red one again. I think the red one looks okay. We'll try something different. Let's try yellow one. So what I need to do in my normal force diagram is now I need to write that. This is 7. This is going to be my normal force. All equal to 0, right? And this over here will be 7. This is x in meters. Right? We got 0 for everything, so that's going to be our normal force diagram. Okay, let's look at my shear diagram. In my shear diagram, what did we find? Right, let's see. We found for my first equation, we found that V as a function of x is 1.71 kilonewtons. So that means that it's a straight line at 1.71 kilonewtons. And for the other one, we found that is this 6.21 minus 1.5x. All right, so one of the things that I'm observing already here, that equation is a equation of a straight line that it has a negative slope because it has a minus 1.5x. And so what I can do is I can evaluate the value of that equation in 2 points, and that's going to find my straight line, right? All right, so let's go back to the other equation. The first thing that we need to do is draw this 1.71 kilonewtons, right? And that's between 0 and 3. And I change back to my yellow. 1.71 kilonewtons. So let's do something like this. This might not be the best drawing, but we'll get the idea, right? There you go, 1.71. This is now in kilonewtons. That's 1.71 kilonewtons. And over here, this is gonna be 3 meters, right? This x is now in meters. All right, now to find the other 2 points, what I'm going to do is evaluate that second equation that we had, this one over here. Let's see, this one over here, that's 6.21 minus 1.5x. I'm going to evaluate it at 3 meters. I'm going to evaluate it at 7 meters, okay? So my V at 3, and I did that offline, so I put 6 point, let's see, where did I do that? 6.21 minus 1.5, and the x is going to be 3. So my V at 3 does give me 1.71 kilonewtons. And I'm also going to evaluate my V at 7. Now at 7, what we have is 6.21 minus 1.5 times 7. I believe this gives me minus 4.29 kilonewtons. Okay, so at 7, we have something around here, and this value over here is going to be minus 4.29. And we know that this is going to be a straight line. Change that to my yellow color again. All right, okay, here you go. This is going to be now my shear diagram. So in this diagram, we're completely describing the shear force anywhere in that element. And that's the advantage of having that diagram. All right, finally, I want to look at my moment, right? So for my moment, I have 2 equations also. My first equation is this one over here. 1.71x kilonewtons meter. And my second equation is going to be somewhere over here. Minus 0.75x squared minus 6.21x minus 6.75 kilonewtons meter. All right. For my first equation, I know it's a straight line, right? Because of the type of equation. And for my second equation, it's going to be some type of a quadratic equation. So it's not going to be a straight line. The first one is a straight line. So what I'm going to do is I'm going to evaluate those at key points, right? So we're going to say that my m, using the first equation, that 1.71x, well, when x is equal to 0, m is equal to 0. So m at 0 should be equal to 0, right? M at 3, we can do 1.71 times 3, and that gives me, I think that was 5.14 kilonewtons meter. That means that at 3, I'm going to continue, this is going to be 3. I'm going to have something like this, 5.14. Right, and this is a straight line. I mean, now I probably put that number in the wrong place because I'm gonna make the line that direction next. Okay, and this is in kilonewtons meter. All right, the second equation, this one over here, going to be some type of a quadratic equation, right? If you go back to your calculus, you should be able to see which direction the shape is going to do and all of that. I'm not going to be too picky right now about that. I just want you to realize that it's not a straight line, that it has some type of a curve. And when I evaluate that, and what you can do actually is evaluate that at different points. I only did it at 2 points, just because I have a little bit more experience, but you can evaluate it at 4 meters or 5 meters and something like that. And you will be able to get different points that gives you the shape of that equation. When I did the m of 3 with that equation, that also gave me the 5.14, which makes sense. And when I did this at 7, that gives me 0 kilonewtons meters. So what I can say based on that is this is going to go somewhere like this. And I apologize that I'm going to have to draw on top of those numbers, but it's going to look something like this. Okay, where this is going to be 7 meters. This is 3 meters, 7 meters. I guess we don't need the meters, we put it here on the axis. All right, so now this graph is actually describing all the moment along the length of that beam, and now this can actually be used for design.